Sigmund Koch, the distinguished American psychologist, often complained that psychology was the only scientific discipline that settled on a method before deciding what its subject matter was. Actually, psychology has settled on its subject matter at least 3 times in the 20th century, only to unsettle itself and adopt yet another reality for its later consideration. Well, the problem should not be attributed to the alleged youth of psychology. True, the first academic laboratories devoted to psychological research, at least university laboratories, don't appear until the last quarter of the 19th century. But academic laboratories for research in any science did not appear until the second quarter of the same century, so we can't say that psychology is young in that respect. Of course, much scientific work was accomplished beyond the narrow gates of colleges and universities, much in the ancient world that had no such institutions. But here again, psychology was not neglected. Depending upon what one requires of a demonstration for it to qualify as research, well, psychological research is at least as venerable as studies conducted by Galen in the 2nd century AD, probably by Aristotle in the 4th century BC. So if there is confusion in psychology, it's not a youthful confusion. It's rather more a species of habitual confusion made durable by practice. Now, it has often been observed that psychology not only is a young discipline, but it's a hybrid science, a hybrid discipline. This designation attempting to reach the fact that psychology's interests range over both scientific and humanistic problems. The same discipline attempts to provide room for those interested in the pigment chemistry of the human retina and those who wish to identify just what it is that makes a joke funny. The very breadth and diversity of phenomena then strike many as excuse enough for the unsettled nature of psychology in its attempts at unity and disciplinary coherence. Well, indeed. But physics has somehow been able to make room for those interested in the redshift of stars retreating from the Milky Way and those whose subjects of interest come into being and out of existence in less than a billionth of a second. Again, though the range and variety of phenomena offer daunting challenges to those who seek integration and coherence, the challenge is no greater in psychology than in physics, unless, of course, there's something special about the phenomena themselves. Not their range and diversity, but something intrinsic to them. Well, the special subject of philosophical psychology also reflects on the disordered state of this somewhat undisciplined discipline. Attempts to create order and system must always be, to some extent, arbitrary, but also necessary, or else there really would be no subject at all. So, psychology. Where to begin? The starting point, presumably, is the identification of what psychology is about, what its practitioners identify as good reasons for having the discipline, what other reasonably informed persons would reasonably expect of it. A dictionary here is helpful, but only in a very limited way. How something is defined, after all, is determined not by those who compile dictionaries, but by the uses and meanings of terms in actual practice. Consider the entry in the Oxford Pocket Dictionary, which defines psychology this way, quote, "Study of the human soul or mind, treatise on or systems of this." Now, in my edition of the Oxford Pocket Dictionary, this is followed by a definition of a ptarmigan as, quote, "a kind of grouse changing to white in winter." So for all the help the little dictionary provides on the matter of psychology, one might just as well have used the definition of a ptarmigan. I don't know that psychology turns white in winter, but you do get the point. A more informing approach than the dictionary approach would be to find an inquirer locate the inquirer in major departments of psychology, where things are examined, courses are offered, texts are assigned, research and writing engaging the residents. Now, these days, very few instances would be found of a study of the soul, and nearly as few of attempts to develop a treatise or system of the mind. Rather, the courses and activities would be highly particularized, focusing on any number of questions that, at best, relate only obliquely to what has traditionally been understood to be human mental life. Who's to blame? Who's to praise for this turn of events? A breathless romp through history might put matters in perspective. Well, let's have the breathless romp. We mustn't fault the dictionary for the word. Psychology is rooted in the Greek psyche, psyche, which was rendered as anima in the Latin translations of the Greek. And anima is the root not only of the English animal, but also, and suggestively, of animated. And this nicely expresses Aristotle's use of psyche, which in his treatise on the subject he defines as the first principle of living things, the arche zoon. For Aristotle, then, what is psychic is a complex process, not a thing occupying a place or having some existence outside the creature that is thus animated. Also for Aristotle, this animating principle is expressed in various ways and confers different powers or faculties on different kinds of living things. In some, the psychic process is limited chiefly to nutrition and reproduction. In more complex creatures, the power of movement is added. Then in even more complex creatures, those that qualify as animals for the first time, the psychic processes include that of sensation, on Aristotle's account. He states that this power or faculty virtually defines an entity as animal. Now, human life includes all of these other processes, and one special one in addition, a rational power or faculty, permitting deliberation and choices based on deliberation. In the same ancient Greek world in which Aristotle was composing treatises on psychic functions, the Hippocratic physicians were recording the reliable association between injury to the brain and disturbances to perception, memory, movement, thought. So here then was an early commitment to what might be called a psychobiological discipline. The medieval and scholastic philosophers tended to fall into either Aristotelian or Platonist schools in their own speculations on the nature of what we call psychological processes. By the 17th century, scientific achievements being what they were, a more daring approach to all this was taken, first by Descartes and then by John Locke. In earlier lectures, I've discussed their approaches and their quite different conclusions. Here I would draw attention to what the two held in common, namely that fundamental questions in philosophy do require a systematic treatment of psychological states and processes. Both Locke and Descartes were virtually inventing psychology as an independent field of inquiry, to be developed by way of systematic observation. Of course, in both of their cases, the observations were introspective. One finds out about mental processes by consulting one's own pattern of thought. It was not until the 20th century that quite cogent arguments against the philosophizing of psychology, succeeded in transforming a philosophical psychology into what many hope to be a scientific psychology. The late 19th century movement towards scientific positivism was quite influential here, as was the comparable impatience with all things Hegelian. Now, in the first quarter of the 20th century, America's John B. Watson, 1878 to 1958, argued for the abandonment even of William James's and John Dewey's renditions, and of all who continued to tie psychology to something mental or reachable only by way of introspection. Watson insisted that for a subject to earn scientific status, its subject matter had to be public, observable, measurable, out there. And as regards anything that would qualify as psychological, well, that finally must be translated into behavioral terms and observations of behavior. His opening salvo to this effect appeared as an article in 1913 in the Psychological Review bearing the title Psychology as the Behaviorist Views It. And the opening lines of that essay leave no doubt as to what is on offer here by way of Watson. Quote, "Psychology as the behaviorist views it is a purely objective experimental branch of natural science. Its theoretical goal is the prediction and control of behavior. Introspection forms no essential part of its methods, nor is the scientific value of its data dependent upon the readiness with which they lend themselves to interpretations in terms of consciousness. The behaviorist, in his efforts to get a unitary scheme of animal response, recognizes no dividing line between man and brute, close quote. Thus spake Watson. Now, the behaviorist movement grew first quite slowly, and then primarily through the influence of B.F. Skinner in an accelerated way. By the 1960s, many psychology departments had come to identify themselves as departments of behavioral science. The famous Rat Lab was now a fixture, most psychologists confident that neither consciousness nor humanity itself presented any barrier to a purely descriptive science of behavior. Three major obstacles continued to support resistance to all this, but we must be clear as to what was included in all this. A purely descriptive science, as if this adverb could ever be correctly used to qualify the adjective, a purely descriptive science of behavior was to be independent of and indifferent to events occurring under the skin. That is to say, the project of predicting and controlling behavior required no support and accepted no challenge from the biological sciences. As Skinner argued, from the perspective of the behavioral scientist, it wouldn't matter if, on examination, the behaving organism was found to have nothing at all inside its body. It could be an empty organism, but would remain the proper object of study if somehow it continued to behave, and if that behavior was shapeable. Similarly, as this science needed no support and brooked no opposition from physiology, it was under no obligation to address questions arising from allegedly mental sources or causes of behavior. On the behaviorist account, the determinants of behavior are to be found, it was urged, outside the organism, in a reinforcing environment, and not inside in the form of thoughts or motives. Given this orientation, it's easy to see just where the resistance and criticism would come from. Psychologists trained in neuropsychology or physiological psychology were all too aware of the utter dependency of behavior on the biochemistry, the electrophysiology of the nervous system. So though supportive of the behaviorists' commitment to an objective science of behavior, they were surely not at all prepared to abandon the important and long productive program of research on brain-behavior relationships. As these were readily observable in the neurology clinic, where introspection has always been a major diagnostic instrument, if you want to know what's bothering the patient, you ask the patient, the theoretical asceticism of the behaviorist seemed as unpromising as it was pretentious. Then, too, any number of studies of animal behavior turned up results that were simply uninterpretable in terms of external determinants. A most influential and suggestive article by Edward Chance Tolman appeared in the Psychological Review in 1948 under the title Cognitive Maps in Rats and Men. Now here, Tolman summarized many of his own studies, all pointing to the cognitive nature of problem solving. These, in conjunction with long-standing research and theory in Gestalt psychology, required the preservation of the mental, the cognitive, if only as a way of rendering the results of behavioral studies coherent and intelligible. Needless to say, as behaviorism strived for hegemony in academic psychology, psychoanalytic theory was still the perspective of choice for much of the larger community of psychologists in clinical and counseling psychology. Offered by Freud himself as a branch of natural science, presumably with family ties to biological and medical sciences, behaviorism just seemed unfaithful to other family members. It provided no significant part or place for the obviously relevant field of genetics. It was stridently anti-theoretical, but with membership in a community of disciplines firmly grounded in theory. It was stridently anti-mental, but then seemed unable either to account for or to develop ways of studying behavior that clearly proceeded from some kind of cognitive internal integration of the environmental inputs. Thus did behaviorism give way to the now ruling rubric, cognitive neuroscience, about which I shall have some things to say toward the end of lecture. But let me return to Sigmund Koch's witty indictment, psychology committing itself to a method before settling on a subject. What is the method? Well, the method is loosely, even disarmingly described as, quote, experimental, but it carries much more baggage than that word suggests. Rather, in most instances, the method of inquiry includes the following main ingredients. First, there is the identification of some response indicator drawn from the behavioral repertoire of a human or animal subject, so-called, that is intended to signify the reception of a stimulus or the successful performance of a task. Now, as these response indicators are sampled repeatedly, the resulting data set then has to be subjected to various statistical tests and analyses in order to determine whether the main findings stand on firmer ground than mere chance effects. So in the usual experimental setting, every effort is made to restrict stimuli or experimental conditions to specifiable types, rigorously controlled, in order to establish statistically reliable relationships between these and comparably restricted response indicators. Just picture the rat pressing a bar. Now, two fundamental questions arise from the adoption of methods of this sort. First, to what extent is such an idealized context representative of the actual world, the actual life in which the events and processes of interest routinely occur? Second, in so restricting the problem or the stimulus sets and the response indicators, is there not a veritable invitation to what William James dubbed the psychologist's fallacy? Do we find in such experiments how persons actually solve problems or comprehend stimuli? Or are we merely calling on subjects to respond as if they see the world the way the experimenter would have it seen? Now, to reduce both of these fundamental questions to a word, what is at issue here is the very validity of the experimental method, to the extent that the purpose of the method is to unearth the manner in which the environment is processed, comprehended, otherwise negotiated by real and different animals, including those who are in the sophomore class. Now, we can highlight the problem of validity by considering a frequently studied phenomenon in psychology, that of emotion. Surely the emotional aspects of life are profoundly important as sources of behavior and as influences on thought itself. States of love, happiness, contentment, anger, fear, hatred, frustration, affection. The list is long, and the items are often the best predictors of what persons actually will do, providing the best explanations for why they're doing it. Thus, a discipline devoted to the prediction and control of behavior, or to the development of theories and models of psychological life, presumably has every reason to examine the emotions with care and thoroughness. However, attempts to do this within the context of a laboratory have proven to be unconvincing, hopelessly narrow, I would have to say ultimately useless for all real-world practical purposes, and the reasons should be obvious, and thus the failure is to some extent pardonable. How does one realistically establish, in a laboratory setting, intense hatred, undying love, deep and enduring happiness? How do you do all this within a 1-hour laboratory session? If mild shock can be used to create anxiety, what intensity would be needed to create a state of dread or panic, paralyzing fear? Would that be permissible, even if possible? Moreover, emotionality generally does not come in the form of one emotion at a time. Real-life instances are complex mixtures, shifting in intensity and vividness and order, subject to sudden alteration, tied in various ways to perceptions and thoughts, often modulated by certain predispositions, at once perhaps hereditary and otherwise bequeathed by a life of experience. Now, if all this militates against laboratory studies of emotion having any broad, valid part to play in our understanding of emotion, then the same reservations must arise when the topic shifts to, say, thought, motivation, memory, social interactions, civic life. To all this must be added questions as to the aptness of essentially statistical modes of analysis in the study of complex processes. There are very few instances in the developed sciences, for example, where the most common experimental model in psychology, namely the analysis of variance model, is employed. The analysis of variance model, which would identify the separate influences of several or even many variables on the occurrence of the event or effect of interest. Now, the relative contribution, for example, of age, weight, level of education, gender on, say, incidence of depression. So you do this analysis of variance, comparable statistical modes of analysis. It has been noted these very modes may actually describe or identify the effects of these variables on no one in particular within the sample of subjects. As there is no family on Earth with 2.27 children, so too there may be no subject in the experiment to whom the data revealed by this analytical model are applicable, or of whom they are in any way descriptive. To reduce this to a set of issues, to reduce this set of issues to basic terms, the question is whether the right approach to understanding psychological processes and phenomena is, two technical terms coming, nomothetic or ideographic. The former, from the Greek nomos for law, is an approach that searches for general laws describing trends and regularities in data sets. The latter, from the Greek idios for personal, is an approach sensitive to the unique and individuated nature of perception, comprehension, adjustments to the surrounding world. It's important to point out here that there is a common misunderstanding within psychology as to the nature of nomothetic and ideographic approaches. It is often assumed that the nomothetic approach must use large samples in order to obtain general laws, these now applicable to group data, though not always to a given individual within the group. This, however, is not the case. In basic research in medicine, for example, in physiology, as in physics and chemistry, the single observation will often reveal the general law. Consider the Krebs cycle, which establishes the manner in which carbohydrates are metabolized. The Krebs cycle was not discovered by sampling thousands or hundreds of thousands of persons as they ate bread. Within psychology itself, the basic laws of visual and auditory information processing, as discovered within the specialty field of psychophysics, these basic laws are based on experiments in which it would be rare for there to be more than a few subjects in the experiment. So the point worth making here is that the nomothetic approach and the nomothetic aspiration are not bound to essentially statistical modes of analysis and may actually be retarded by such modes of analysis. There is all the difference between a method that relies on the mere counting of numerous instances and the actual measurement of any one of them. Counting is not a mode of measurement. Now, left aside in all this is whether or not the very search for general laws makes any sense in light of the several aims ordinarily associated with psychology. Presumably, a discipline striving to explain and predict human behavior or human mental life, or more grandly, human life at large, must confront the objections leveled against Hempel's model of explanation. As it seems utterly unsuitable in accounting for or explaining historical events, why would there be confidence in its application to any complex psychological phenomenon? Put another way, to the extent that neat and basic laws are unearthed in the psychology laboratory, one might ask whether what has been found to be lawful in that case is, in the end, relevant in any way to the larger mission of understanding life as lived. To the extent that the discipline is or aspires to be scientific, yet another set of questions will arise as to the proper model or template, for science itself is not singularly committed in this regard. Modes of measurement, experimentation, theory construction, theory validation are different in particle physics and in classical mechanics, in inorganic chemistry, in evolutionary biology. The pairings should be obvious. There would seem to be a much more natural tie then between psychology and the biological sciences, but the connection here is not an easy one to establish, as will be clearer in the next lecture. So being neither a physical science nor patently a biological science in the strictest sense, psychology has evolved, some might say, willy-nilly, as something of a, well, I do hesitate to use the term, well, something of a kind of engineering science, but in respects that are surely not faithful to engineering. And let me try to make this important point clear. The general approach in engineering when facing a challenge to develop a device or technique to solve a problem is first to reduce the problem to a model of some sort. The model itself typically includes a number of distinct modules, each having a function necessary to the operation of the system as a whole. Attention is then paid to giving the modules such properties as allow not only the given function, but a means by which that function can be integrated into the performance of the overall system. Now, as a strategy, this approach can point to no less a group of authorities than Newton, Boyle, Galileo, Descartes in the 17th century, a whole army of productive and creative disciples ever since. Following this rationale, psychology, in its experimental and theoretical productions, attempts to use the laboratory context as a simplified model, with experimental variables chosen to, as it were, tap into one or another function, one or another functional module necessary for the system to perform as a whole. Perhaps the most successful, or at least the most obvious application of this line of thinking is what animates contemporary cognitive neuroscience. The core assumptions are, first, that any cognitive achievement, no matter how complex or context-dependent, is finally reducible to an ensemble of distinguishable functions. Second, each of those functions is accomplished by processes and networks in the nervous system. Finally, that the manipulation of relevant variables within controlled conditions of the laboratory will be the means by which to put thought and action on a scientific foundation. And just in case anyone doubts it, well, we now have functional MRIs indicating not only that there are such modules in the brain, but even which ones are at work. But you know, it really doesn't take too much by way of objective distance from such optimism to begin to see that the entire undertaking rests on a set of confusions and a few mistakes. To begin the critical appraisal, it's important to understand the difference between an engineering model that actually does perform, say, a filtering of a class of input signals, and some sort of cognitive event that might be interpreted as if filtering were taking place. When Jack ignores what Jane is saying, we can provide a model of the failure to record the utterance. But it would be hazardous to say that all that is taking place is filtering. To add another box, say one with the label "filter unpleasant inputs," is a game anyone can play, but surely not one on which the profession of engineering would depend. Jack's filtering is a very active sort of thing. Apart from this, there's widespread confusion as to what should count as a model of something, and what it is that is finally modeled. Consider the task of getting dirt off the floor. In one instance, Jack sweeps the floor and puts the dirt in a dustbin. In another case, Jack uses a vacuum cleaner. And in a third case, a robot is designed which operates the vacuum cleaner. And in another case, the robot sweeps the floor. Engineers analyzing what it takes to get dirt off the floor may build a number of models before producing the robot. What is modeled here is the process of removing dirt. It would be odd to think that the robot was a model of Jack, and even more odd to think that floor sweeping is a model of vacuum cleaning. As Norbert Wiener, the father of cybernetics, once said decades ago, The best model of a cat is a cat, preferably the same cat. Leaders in the cognitive revolution have been aloof to an especially fruitful set of possibilities arising from the Wittgensteinian quarter. There's great attention in psychology to language and language development, but very little to the productive use and constitutive power of language. Much of the confusion in psychology, philosophically understood, is based on a kind of grammar, a kind of reckless or unattended grammar that leads us to believe we are modeling X when in fact we're modeling Y, or may not be modeling anything at all. Time to step back, re-examine the methods, get clear on just what it is we are trying to model, and then clear on whether what we are trying to model can be modeled except through life itself.